Hello there, friends and neighbors. I'm going to show you how to write a complete results section for chi-square test of independence. This is what you use if you've got two categorical variables where at least one of them has more than two groups, and you want to see if they're related. Now, strictly speaking, it also works if they're both binary, if both variables have two groups. Okay, the typical results section has these components, and in your introductory class, they are all required for a results section. Looking for descriptive statistics, those are just sample proportions and sample size. Graph, it's a bar graph. And inferential statistics, which requires the null, alternative, and alpha. Assumption check, the mathy part, the confidence interval, test statistic, degrees of freedom, p-value. We won't get a confidence interval for this one. It doesn't work that way. Make a decision about HO, and interpret the whole thing in plain English. So let's go ahead and get started. Statistical analysis, discrete variables. All categorical variables will be treated as discrete. Then you go to create two-way table and compare two proportions. Fisher's exact. I'm going to click on that. And what they've got here is age group, which is like 5 different age groups, and whether or not you know how to change a tire. Right? So they've got a categorical input, which is age group, and a categorical outcome, which is yes or no, do you know how to change a tire? By convention, we make the column be the outcome variable and the row be the input. I choose row percentages. Those are my descriptive statistics. I choose chi-square and components. Those are my test statistic. I choose the expected frequencies, which is how I will check my assumptions. They must all be at least 5. Turn off the Fisher's exact, and turn off the continuity correction. Then you click OK. And it gives you everything but the graph, so I'm going to produce that soon. I want to get my row percentages here. I'm going to copy this table. These are my descriptive statistics. Right click, copy. Go to my Word document. Right click, paste. Select it all and make it legible by making it a monospace font like Courier New or Courier. You can see there are 1, 2, 3, 4, 5 age groups. Under 20, over 50, 20s, 30s, 40s. And 57% in the sample of the 20s know how to change their tire. In the sample, 60% in their 30s know how, and under 20, 70 or 67%. The counts, the sample sizes are very small, 3, 7, 8, 5, and 7. Not nearly enough for this many groups. Okay, and I've got to add those up to determine what the sample size is. So 7 plus 3 is 10, 18, 23, 30. So n equals 30. That's it. That's their descriptive statistics. Now let's go get a graph. Graphs and tables. Bar graph. The variable is going to be change tire, and we're going to group it by age group. I'm going to draw it in color, put groups side by side, and compare proportions in each group. And click OK. Now, if you've got a Windows or a Mac, you just right-click and copy this. I am using Linux, and mine's setup is a little bit different, so I'm not doing it that way. But it's not too bad either. I'm going to just copy that image, paste it to my editor, select, cut the image, go to my word processor, paste it, anchor it as character, make it smaller because it's too big, cut it, and paste it. Okay, and that's what I'm going to do. Okay, next, I don't need this anymore, put that away. Okay, now, next comes our inferential statistics. So HO, H1 alpha. This is really simple. HO for chi-square goodness of fit test, it's always the same. The row variable is independent of the column variable. That is, there's no difference among age groups in whether or not people know how to change their tire. That's the null hypothesis. The alternative is row and column are related. You choose your alpha, can be anything you want, but 0.05 is the commonly accepted one. The assumption check, of course we assume independence, which is achieved by simple random sample. Then we're assuming that all expected counts are at least 5. And they're not. We're going to violate this assumption. That's okay. So let's go look at what we ran. Okay, already ran it, so I'm going to scroll up until I get to the expected counts. There they are. I'm going to copy this. Copy. Go back to my word processor. Paste. Select it and make it look pretty by making it Courier New. Boom. And as you can see, in fact, only 3 of them are actually big enough. So the smallest expected count is 0.6. That is smaller than 5. We do not meet the assumptions. This test is not valid. But we're going to do it anyway because it's a class project and I want to show you how to do this. So we'll move on, and now I'm going to look at the chi-square, degrees of freedom, and p-value. Copy that. Paste. There's no confidence interval here. So here we say the p-value is greater than alpha. So we fail to reject HO. Now interpret that. What that means is there is not sufficient sample evidence to support the claim that age group is related to knowing how to change your tire. That's that. It's a complete result section from beginning to end.